Destructive plate boundaries occur when plates move apart from each other. No, move towards each other. Sorry, I'm getting confused. I'm very tired. Um, the way I sort of remember it is destructive and convergent, and constructive and divergent. So C and D, they sort of match. So destructive convergent means they are going towards each other. That is my bad. Bruce, I'm human. There are actually three types of boundaries: continental, continental, continental oceanic, and oceanic oceanic. A lot of words, but you can get through it. So a continental continental boundary. An example of this is between the Indian and Eurasian plates, and when two continental plates collide. So because they're both the same, the continental plates have the same density, so neither plate actually wants to get sucked down into the mantle. We will later come across this as a process called subduction. Now, both plates actually buckle upwards and sideways to prevent either one from sinking. The tensile forces released during the slow movement of this collision can cause shallow earthquakes, such as one that occurred in Pakistan in 2005. A result of this is actually fault mountains, such as the Himalayas. So as you can see here, we have the two plates colliding, so Eurasian and Indian. They buckle upwards, as you can see by this folded rock, and form fault mountains, such as the Himalayas. The next kind, continental oceanic, occurs between the South American and the Nazca plates, which is an oceanic area west of Peru. You can look back at the plate tectonics video to see where that is. Now, the oceanic plate is heavier, so it actually gets subducted into the mantle. The material is reused and recycled, which is going to get pushed back up through either a fissure or in the constructive plate boundary areas. Now, deep earthquakes occur in these areas, and actually our case study for volcanoes, Mount St. Helens, is actually in an area where deep earthquakes occur, and so erupted. At the crossroads of the two plates actually lies a long ravine, although we don't use the word ravine for underwater ones. We call it an oceanic trench. And trenches mark the subduction zone. So, as the subduction is when the plate goes underneath into the mantle, and the subduction zone is actually essentially, as I said, the point of no return for material. The deepest one that we've currently found is the Mariana Trench between the Philippine Pacific plates, I believe. And particulates, which are carried by the seafloor, don't have enough energy to be subducted. So they might actually, because they're so loose, they might actually get pushed up instead of pushed down, which is a bit weird. And they form little deposits known as terranes. So, as you can see, the Nazca plate is getting subducted by the convection current. The trench forms here, which is in the subduction zone. We can also have fold mountains form, such as the Andes Mountains. And for all the Minecraft players out there, yes, that is where we get andesite from. It's found within the Andes Mountains. And the terrains are here. I do apologize for my bad handwriting. I did kind of draw this rather quickly. So actually, in terms of continental oceanic, there is a case study that we do. I completely forgot about, looking on my other screen here. And that's what's known as the Pacific Ring of Fire, which is this area around the Pacific which has a lot of tectonic activity. So see, we have a bunch of trenches in here. So we have the Aleutian Trench, which is where we get the Aleutian Islands from. The Japan Trench, the Marianas Trench, a Philippine Trench, Java Trench, the Tonga Trench, which is actually what caused, I can't remember the name of it, but it was a recent enough eruption in Tonga. So those are all the trenches. And this area, as I said, contains most of the world's volcanoes due to the Pacific plate being destructive. And of course, it's absolutely massive. One volcano that's on here is Mount Fuji in Japan, but also we have Mount Pinatubo, which we will discuss in great detail due to its fairly recent eruptions. So now we have the last one, which is oceanic between the Philippine Pacific plates, so it's oceanic there. Large trenches may form, but they are normally much deeper. So as the Mariana Trench is nearly 11 kilometers deep. And the 2011 Japan earthquake also occurred here due to a deep earthquake. When magma releases from the subduction zone, where the two plates, or where the heavier one gets subducted under, it creates what's known as plumes, which is like little bubbles of magma, which then solidify and turn into chains of island arcs. As you can see, the Aleutian Island is one of them. So these the tiny little lines that spit off of Alaska are formed due to that. And then, of course, we have our diagram. So the Pacific Ocean is here. We have the Pacific plate subducting under the Philippine plate. And, of course, we get the island arcs of the Philippines. And Mount Pinatubo is actually near enough on this kind of boundary. Now, as I said, we're going to be talking about the Mariana Trench as our case study. So it's the deepest known point we've found so far in the Earth's oceans. This isn't it, by the way. This is just what the seafloor looks like. The deepest part of this trench is known as Challenger Deep and was visited by the director of Titanic, David Cameron, in 2012 in the Deep Sea Challenger mission. During missions down to the trench, actually, they found evidence of simple algae, so tiny, tiny microorganisms, as well as microplastics. One dive in 2019 actually found candy wrappers and a plastic shopping bag somehow found at the bottom of the trench. Which is, bad for the sea life, but the sea life have actually survived due to a high level of carbon-14. So if you did history, carbon-14 dating is probably enough, but they found abnormally high levels of carbon-14 because this is actually a place where some governments do nuclear bombs testing, or at least in areas around it. So that's really all for destructive plate boundaries. There is a lot, but it tends to be a nice one to do an essay on.